The next type of energy we'll talk about is potential energy. Uh, Potential energy is what we call stored energy. Uh, you can have stored energy because you have a height above a certain reference point. Uh, that's what we ref- that's what we refer to as gravitational potential energy. These two stationary objects, all the stationary objects, I should say, the guy hanging there on the cliff, the globe, the books, the apple, they all have uh, a stored potential energy because of their height above some reference point. His height above the ground that he could fall to below. Their height above the globe and book, and Apple's height above the floor that they could fall down to. They have this potential energy, and it's stored. You can have potential energy in other things, like a spring. If you compress a spring, you give it a certain amount of stored potential energy. Uh, Batteries have electric potential energy. Uh, there's a stored amount of energy in those batteries. Okay, the one we're going to be focused on for the next couple weeks is the gravitational potential energy. What we, will call gravitational potential energy, but we'll just refer to it as potential energy uh, in shortened form. And potential energy for stationary objects that are above some reference point, uh, the formula for that potential energy equal mass times gravity, acceleration due to gravity, times the height above whatever reference level we're talking about. Or some people might call it the zero potential energy line. So let's look at a couple examples. The first example we have is a 30 kilogram child climbs up a 15-meter tree. Climbs 15 meters up a tree. When he stops, what's the potential energy? So potential energy equals mgh. So the kid's 30 kilograms. That goes with mass. 15 meters. That's the height. Gravity 9.81 meters per second squared. So mass 30, 9.81 times 15, 4,410 joules potential energy. The next one, we have a 37 Newton object that's lifted to a height of 3 meters. This one's a little different. You need to recognize that this is the weight of the object, and potential energy being equal to mgh. Well, mg is weight. Okay, so you already have weight, and it's going up a height of 3 meters. So in this case, they already tell you what m times g is. It's 37. So we can plug that in for mg. The height is 3 meters. Potential energy is equal to 111 joules. 3, you have a box with a mass of 5.8 kilograms. The box is lifted from the garage floor and placed on a shelf. The box gains 145 joules of potential energy. We want to know how high is the shelf. Okay, this is just slightly different where they give you the potential energy. Now we just want to calculate what the height is. Well, use the same formula. Potential energy equals mgh. Plug in what you have. We have potential energy, we have mass, we know gravity, solve for height. Potential energy 145, mass 5.8, gravity 9.81, height we're going to solve for, multiply these two, and then divide both sides by that answer to get your height. 5.8 times 9.81, 56.898, divide both sides by 56.898, and the height is equal to 2.55 meters. The last one talks about a man climbing onto a wall that is 3.6 meters high, gains 2,000 268 joules of potential energy. We want to know what the mass of the man is. Okay, so the mass of the man will be solved through the potential energy equation. Potential energy equals mass times gravity times height. In this case, we have the height, we have the gravity, we have potential energy, and we're going to solve for mass. Plugging those numbers in looks like this. And then we're going to multiply 9.81 times 3.6, divide both sides by that answer. Mass is equal to 64.2 kilograms. Keep in mind that you need to make sure you're in fundamental units. If you're not going to use a unit analysis, so joules is. Keep in mind that joule is a kilogram times a meter per second squared times a meter. Okay, that's a joule. So you need to have your units correct. Okay, so if somebody gives you 5.8 grams instead of kilograms, convert that to kilograms before you start multiplying into joules or calculating your potential energy or kinetic energy.